Good evening, algebraic students. This is lesson 14, and this is, no pun intended, but this is a lofty lesson. This lesson really is tying a lot of what we've learned together. So projectile motion is basically the idea of things moving through space. And we have gravity that impacts how things fall and how things actually move through space. We have acceleration that's dependent on things like if you're throwing a soccer ball up, how it's going to, where you're throwing it, how it's going to come down, how gravity impacts it, and how it accelerates. So for a lot of these types of problems, you're going to see that an equation is already provided for you. So you don't have to translate a lot of this information into your own equation. The equation is already provided. So, and this is basically designed to give you a snapshot into how you would solve a quadratic in a real type of situation. So that's the goal here. So if I look at number one, and by the way, you should have a calculator. Like if you have a phone or something like that, have a calculator. It will be very helpful because there are going to be some larger numbers here to deal with. And there's going to be something that's going to come in handy, and that's going to be our axis of symmetry formula. So if I'm solving a quadratic in standard form, if I think back to something like, x squared plus bx plus c, right, equals y, something like that. A lot of the things we learned early on in our unit was that we could, if given values, like for a, b, and c, if I were given values that I can actually, there is a way that I can solve for x. And that was that axis of symmetry formula, but that's going to come in handy now. So definitely write this somewhere at the top. So again, if you have a formula, and notice it doesn't need a c. I mean, if there's a c, that's fine, but it doesn't. This formula does not require a c. And this will give you, if you plug in some values, this will give you your x value. And then you could always plug that, whatever you get for x, back into the equation to get your y, which would give you something like a vertex, for example. That's what we did early on. Well, we're going to come back to that now, and it's going to look a little bit different. It'll just take a little bit of practice. So let's read it. So we now here, it says I have a soccer ball kicked from the ground with an initial upward velocity of 90 feet per second. And this is modeled by an equation. And this is the equation right here. H equals negative 16t squared plus 90t. You'll see this negative 16t squared in a lot of these kind of falling object type of projectile motion types of problems because it accounts for gravity and acceleration and more type of like physics problems. So if I keep reading this equation that's given to you, so you don't have to create your own equation, but this is offering you, or gives you the height. So the h is the height of the ball after t is how many seconds, okay? So it says find the maximum height of the ball. So if I just drew a silly little picture of this, right? If I'm standing here and I kick a ball and it does something like that, it's kind of like a parabola, right? What it's really asking is, what is the maximum height of that ball? That's the first question it's asking. Okay, so it's basically, it's kind of asking me to, in essence, find a vertex, right? So the maximum height of the ball, I'm going to use the vertex to find this, okay? So let's go ahead and start analyzing like what we have for A and B right now. So in this expression, notice that we're so used to x's, like pretend that this isn't negative 16 t squared, but it's x squared, right? Plus 90x. We're so used to seeing the x's, and then maybe this is y instead. Instead, you could kind of think about it like you write your x and y, if that helps. But we're just using different variables, okay? So if let's start attacking this. So the first thing I'm trying to do is, it's kind of like I'm trying to find my x, right? If I had this equation, but we don't have x's, we have t's. So really, we're gonna first find our t. We're gonna solve for t. So I'm gonna use my axis of symmetry form to find my x, which is really my t. So before I do that, well, let's just make sure that we know our a and our b values, since those are the values that we need. So our a, which is our quadratic term, is equal to negative 16, right? This is our a. And then our b is equal to that linear term, so it's that 90t. Okay, so those are our two knowns. Now I'm just going to plug it in. So t equals negative b. So negative 90 over 2 times a. So 2 times a, which is negative 16. And now I'm going to solve this out. I should have given myself more space, but that's okay. So if I keep going and keep simplifying this, I should have negative 32 on the bottom, negative 90 up on top. And when you put this into a calculator, and again, use a calculator, I would definitely use a calculator. You're going to get something like 2.81, okay? And if you need to round in any of these problems, just always round to the nearest hundredth. So what does this mean? So I just got the time, right? 2.81 is part of my height, right? But it's not the height, it's the time. So what I'm really trying to do, and if you remember going back lessons ago, when we found our x, right, we substituted whatever that x was back into the standard equation to get our y. Well, we're doing the same thing, but we're doing this with t and h. So this is t. So I'm going to substitute that value for t back into this initial equation. And so I'm going to rewrite this like h equals, now here I have negative 16, and then I have my t squared, which is 2.81 squared, plus 90, and then I have another t here, so I'm going to put that 2.81 back in, okay? And when I calculate this out, so I am not going to sit here and calculate it for you because I did put it into a calculator. So I squared 2.81. That's what I started with because that's order of operations. Multiplied it by negative 16. And then I multiplied these together and added this to this side. And I end up with 126. And I urge you to use a calculator and make sure that you get the same answer. 126 and 56 hundredths. But what does this really mean then? It's, we have a couple of things here. So first of all, we have our h value. So I'm going to do this one more time. All right, that's our h. That's what we were trying to get. We were trying to get our height. We found our height by getting our time, plugging it in, and getting our h out. Okay. So that is the answer to 1A. So it's 126.56, and again, that is feet, okay? Okay, so we have another part to this here, and that is, I'm going to scoot it down a little bit. B, how many seconds will it take for the ball to reach the ground? So if I go back up to here, right, so this is going to be its height, right? But let's just pretend this got, wow, that's pretty high. It got up to 126, right? About 100 27 feet about, right? So it's asking how many seconds will it take for the ball to actually get to the ground. Okay, well, what is the height at the ground? If you think about it that way, well, the height at the ground is just 0. Okay, so what I think that just kind of means I'm setting this to 0. Okay, so here we go. And I like to put the trinomial, if you will, or the standard form on the left and my 0 on the right. So you'll see me do that. But I'm going to rewrite this as negative 16t squared plus 90t. And guess what I'm doing? Well, here I could write h, because I'm just literally rewriting this equation here. But h, we actually now know what h is. H is 0, because that's the height at the ground. So instead of h, I'm going to erase it just to show you. I'm actually going to say that h is now 0. We actually know what h is. So if I have a known, now I can solve for t. And that's exactly what I'm trying to do, because it's how many seconds, right? So I'm looking for that t if h is 0. Okay. So now I can use some of the skills and the strategies and methods I've used to simply factor this out. So if I look at this, I see negative 16t squared plus 90t. I know they're both even, and I know there's a t in both sides. So I'm actually going to find the greatest common factor. So I'm going to put that all over negative 2t, okay? When you factor something, you put it aside, and then you divide it out. When I divide this out, I get 8t minus 45 equals 0, okay? And now I can set both equal to 0. So first of all, negative 2t equals 0. Well, then that doesn't work, okay? So it's just 0, okay? So we're looking for the other t. So 8t minus 45, I'm going to rewrite this over here. 8t minus 45 equals 0. And this is going to end up being 8t equals 45. And then I'm just going to divide by 8, 45 divided by 8 is going to be, and I used a calculator for this, okay, is that. So again, what that equals is, that is your time, okay? This is how many seconds. It's going to take about 5.5 seconds, right? A little over 5.5 seconds for the ball to get back to the ground after it reaches this staggering height of 126 feet, right? Falling objects fall very fast. That's one of the lessons you can learn here. And remember, if you have like a t that is equal to 0, that's not going to be like, it's not going to be 0 time. That can't be one of our solutions, because we know it's going to take a little time for a ball to go through space and land. So that one cannot be a solution. So all of this is to say, this is one very big problem, is that B, again, it's the time. So it's going to be 5.625 seconds. Okay? Okay. So let's move on to our next one. Okay, so number 2, and I'm probably just going to model the front page. So let's zoom in a little bit. Okay. So now we have an apple launching party. An apple is launched directly upward at 64 feet per second. So it's going pretty fast from this platform. Okay. So if I were to draw this out, maybe I have a platform right here, right? It's like 80 feet tall, and I'm just drawing a visual, and I'm like chucking the apple up, right? And it's going pretty fast up, right? The equation, and they're giving you the equation. The equation for this apple's height at the time of t seconds after launch is this. So this is now if you look at this is a standard form basic trinomial. find the maximum height of the apple. Okay, so we're looking for like how high is it going to be when it's all the way up there before it starts to fall back again. So we're going to do this, we're going to solve this the same way. So the maximum height, okay, so I'm going to rewrite this again. X equals negative b over 2a, okay. Now remember, the other thing I could say is I could actually just say t equals negative b over 2a now, because t is my x. I'm also going to identify with my my standard, I should say trinomial in standard form. I have a, let's see, a is equal to negative 16, b is equal to 64, and c is equal to 80. Not that I necessarily need that, but it's nice to identify them anyway. So now let's just plug it in. So t, the time, is equal to, let's see, I need my negative b, so that's negative 64 over 2 times negative 16. That equals negative 64 over negative 32. Notice there's always going to be a lot of these negative 16s because it has something to do with physics. That fits in nice and neatly because I can just divide it out and I get a nice number of 2. So our time is t, and that's 2. So that's our first value, but don't forget, that's not the answer. I need to plug this back in to get my h, because I'm trying solve for h. That's my goal, okay? So I'm going to plug this back into my original equation. So h equals negative 16, 2 squared, plus 64, and remember my t is 2, so whenever I see a t, I put 2 in, substitute 2 in, plus 80 equals, and when I put this all through a calculator, I'm not going to model that, but I am going to tell you that I get 144, okay? So 144, that is the h. The h stands for the height, so that is the answer to 2a. So it's 144, and this is all feet, okay? Okay, so how many seconds will it take to so we have another reach the ground. So hopefully you notice now that if an object is reaching the ground, I can automatically say that h is equal to 0. I'm basically setting this equal to 0, okay? So let's rewrite it now. So I have negative 16. I'm just rewriting this. Let's see, can you see it? Yeah, you can. I'm just rewriting this equation down here, but I'm setting it equal to 0, and I'm solving it, finding its solutions. Negative 16t squared plus 64t plus 80 equals 0. And then I am going to, 16 goes into, that's great. I'm going to factor out the 16, okay? So I'm going to put the 16 aside, and I am going to end up with another basic trinomial. So when I divide 16 out, I end up with t squared minus 4t minus 5, okay, equals 0. And now I'm going to do another set of factoring. If I factor this trinomial out, I end up getting, and I'm going to do the product sum game, and I could make my little puzzle here, multiply negative 5 combined to negative 4. I'm going to end up with negative 5 and 1, okay? So t minus 5, I'm getting it into this factored form, and t plus 1 equals 0. And then I'm going to set all of these equal to 0. Well, negative 16 does not equal 0, so that doesn't have anything to do with it. In my factor that's t minus 5, well, if I set that equal to 0, then t equals 5. And then here, t equals negative 1. Well, remember, I can't have any negative solutions because it's not going to be negative time. So the only solution that works here is the only positive solution, which is 5. And guess what? That's the answer. So it takes 5 seconds for the apple to reach the ground. Okay, so t equals 5. Okay, so 5 seconds. Let's see, we're at 20 minutes. Okay, I feel like I should do one more and then I'll call it. Science class. So the students are asked to create a container to hold an egg. Oh, we've got an egg drop, I think. Then they're going to drop the container from a window that's 25 feet above the ground. Now they're giving us the equation. The equation of this pathway is modeled by this. Okay, so it's not a trinomial. Okay, it's just a binomial. How long will it take to, I don't know. Right now, maybe you should predict, right? If you're 25 feet off the ground, right? Let's see, maybe it's outside my window at school, 25 feet. How long will that take to reach the ground? I don't know. Can you count to 5? Or is that too long? Would it take 1 second? Anywhere from 1 to 5 seconds. You can make a little prediction now if you want. Anyway, so let's find the maximum height of the container. So this should look awfully familiar now. So we are using this t equals negative b over 2a. Let's evaluate. Let's identify what our b is. B is equal to, oh, do we have a b? We don't, but we do have a c because that is a constant. So this is going to look a little different. That's kind of cool. Okay, so let's start plugging in over here. So I have t that's equal to, well, if you do not have a linear term, if you don't have a b term, then that's just 0. And it doesn't actually even matter what's down below, even though I can model it. Well, 2 times a is negative 16 again, isn't it always? It doesn't matter, I get 0, right? So t is 0. Now if I'm going to plug that in because I'm trying to solve for h. Okay, so I'm trying to solve for h. So I'm going to plug my t back in, which is 0. So the height, or h, equals negative 16, and I'm taking it from here. T squared plus 25, okay? Well, this already gets wiped out, so really, h is just 25, okay? So we have a height, right? Find the maximum height of the container. Okay, so the maximum height of the container, well, we kind of already know that. It's 25. Because it already told us, right? It's 25 feet above the ground. That's kind of silly. I don't think you even had to do any of that, right? How many seconds will it take for the container to reach the ground? Okay, so remember, our height is now a given. So our height now equals 0. So we're going to set this equal to 0. So I have, let's see, negative 16t squared plus 25 equals 0. Now this looks like I could use square roots here. If I use square roots, I want to get the equal sign between these two. So what if I add 16t to both sides? Okay, so now I can have 25 equals 16t squared. And now, well, what can I do? Can I take the square roots? I think I can, right? So, I could get rid of the 16, but let's see what would happen if I did this, right? If I took the square root, right? 25, square root of 25 is 5. The square root of 16 is just 4, right? 4 t, right? And then t, I'm just going to divide up my 5, right? Is 5 over 4 is equal to t, okay? And remember, it's going to be positive or negative. Okay, so if I convert this into, because I'm looking for seconds, so 5/4, I do want to convert that to a decimal. And if I divide 5 by 4, I'm going to get that t is equal to 1.25. And that, my students, is how many seconds it's going to take for this container from my classroom at school to reach the ground and maybe possibly hit somebody, but I really don't want to, so I have to be very careful. Okay, so the rest of these problems are going to be a lot like this. Okay, you can always look at the answer key, but I hope that helped. I would, practice as many as you can. Don't forget, if you're looking for something at, let's see, hitting the ground, you're going to set your h to 0. If you're ever trying to find your height, you are going to find that t first and then plug it back in to then try to substitute to get your h out. You can look at the answer key if it helps, but please reach out if you have any questions. This is a kind of a big topic, but I wish you luck.